All right, so hello again. Here we are, another question. This is going to be Iterator for combination, number 1286. Let's just take a moment to make sure. Let me take a moment to make sure the audio is working. Number 1286. Let's just take a moment to make sure the audio is fine. Let me pop out the chat. Okay. All right. So what I want to do is try the next question. Yeah. Iterator for combination. Okay. I don't know about this one. We'll see. Iterator for combination. Design the combination iterator class, combination iterator strings, characters, int combination length, initializes the object with a string, characters of sorted distinct lowercase English letters, and a number combination length as arguments. Next returns the next combination of length, combination length in lexicographical order. Has next returns true if and only if there exists a next combination. Okay. Example 1, input combination iterator next has next, next has next, next has next. Right? Null, AB true, AC true, BC false. Combination iterator, iter, new combination iterator ABC2, iter next, iter has next, iter next, iter has next, etc. Right? Constraints 1 less than or equal to combination length less than or equal to characters that length is 15. All the characters of characters are unique. The most 10 to the fourth calls will be made to next and has next. It's guaranteed that all calls of the function next are valid. Okay, very high acceptance rate, but pretty low, relatively low submission rate. So this is probably a harder question, harder medium question. Okay, initializes the object with a string characters of sorted distinct lowercase English letters and a number combination length as arguments. Okay. Excuse me. Returns the next combination of length, combination length in lexicographical order. Has next returns true if and only if there exists a next combination. So next returns the next combination length. True if there exists a new combination, next combination. So the there's a permutations or iterator or permutations algorithm in this C++. STL, which I tend to forget. I just don't remember. Don't remember exactly how this works. Excuse me, but it does something kind of peculiar. So it actually uses a binary search. Okay. Yeah. I went through this the other day, kind of went slowly through it. So it does use a binary search at each iteration. Okay. Could take a linear number. It could take a linear amount of time, actually. But it uses a constant amount of time, amortized constant amount of time over all the permutations. Very interesting. Very interesting approach, algorithm. And I assume there's a comparable algorithm for combinations, right? So this is not something you would really know how to do unless you had a little bit of experience with this sort of algorithm, right? Like this is one of those things that, like, if you didn't study this beforehand, it's gonna take you a while to kind of come to, figure, understand it. All right. Let me see here. Let me see. Let's do. Excuse me. Okay. Okay. Anyway, sorry. I'm like, mine's like wandering. This is not obvious at all how this works. So we'll just go over it again with permutations, because a combination is similar to permutation, but it's not quite the same. Combination is basically actually, I don't know what exactly combination should be considered. So this permutation, this refers to a full permutation. There is such a thing as a permutation that's like only partial. I forget what you call that. Partial permutation, one of another. Is that right? Permute. How does it work in math? There's like a 5PR, 5P3 or something like that. I don't remember what I'm thinking about here. There's something I like regular permutations. I understand that. That's what this is for, but I don't know. Where is Wolfram? That's what I want. Wolfram. Okay. There's another thing regarding permutations. It's relevant here. Or is it just combinations I'm thinking of? Like, I just remember this there you go to the wiki. I remember this notation that was like you use two numbers with the permutation. Maybe I'm misunderstanding that or misremembering something here. The wiki should hopefully give me a little bit better. Somewhere here, partial permutations. Yeah. Yes. That's what it is, a partial permutation. There is such a thing as a partial permutation. I believe. Or am I wrong about this? Maybe I'm wrong about this. I don't know. What am I thinking here? There's like, it's not partial. I just remember this being like, there's this NPR notation that maybe I'm just misremembering things, which happens from time to time. This is it. Yeah. This is the one. K permutations of n. That's what I'm thinking of. Partial permutation, it is. Yeah, sequence without repetition, variation, or arrangement. Ordered arrangement list of a k-element subset of an n set. The number of such k permutations, k arrangements of n is denoted previously by such symbols as p. Yeah, this is exactly what I'm thinking of. Yeah, I was gonna say, I was like, I'm pretty sure. It's basically just a falling factorial. That's all. Well defined without the assumption that n is a non-negative integer and is of importance outside of combinatorics as well. It is known as the Pochhammer symbol, or as the kth falling factorial. There we go. Power n k. Yeah. This usage of the term permutation is closely associated with the term combination to mean a subset. A k combination of a set S is a k element subset of S. The elements of a combination are not ordered. Ordering the k combinations of S in all possible ways produces the k permutations of S. Yes, this is the part that's important. The number of k combinations of an n set, Cnk, is therefore related to the number of k permutations of n by Cnk is equal to Pnk over Pkk, which is n, Pnk over k factorial, which is n factorial over n minus k factorial. These numbers are also known as binomial coefficients. They usually denoted n choose k. The reason why I'm mentioning this is because there's a relationship between a k combination and a k permutation, the k combinations of the k permutations, I probably could use the next permutation code here to also come up with a way to get the next combination. That's why I'm going through this here. Excuse me, why I'm thinking about partial permutations, because it's not a permutation, right? It's not a permutation, like this is the full permutation. If I could modify this for the partial permutations, then I probably could modify that for combinations, which are almost by definition partial permutations. They're they're unordered partial permutations, though. There isn't really an ordering for combinations. I might not actually need to go that far, though. This may be easier than all of that. I could probably go for something straight through that's not that hard. Like maybe I could actually think up something on my own instead of trying to adapt those other things. This might actually be easier than I realize, which is likely the case. But if it's not, then that's another approach I could take if I get stuck. Let's see. So, okay. So I get these sort of distinct characters. So it starts off at the beginning anyway. And I want each combination in lexicographical order. Okay. So the other piece of code here, and I could probably close these. What we do, if R first, R last, left is sorted until R first, R last. So it goes from right to left, checking that it's sorted, so it's descending in descending order on that side. And if this doesn't go all the way to the end, if it's not all the way in reverse order, right, then I can search. If it is all the way in the reverse order, then it just reversed the whole thing, I think. Left base is an interesting. This is an interesting. Interesting function. I looked at that the other day too. It's kind of cool, useful. It basically takes your reverse iterator and converts it to the forward iterator, the other direction. Excuse me. Left to right, left's our last. Okay. So what happens is you have your reverse iterator. You've got this left side is sorted until right to last. Right to left, excuse me, right? And this gives me, I think, the pointer just after. And if this isn't going all the way to the end, then I'm going to do an upper bound from right to left to that point and dereference that value. So yeah. So wherever, yeah. So if I dereference that, so that pointer left side is going to be all the way past everything that's sorted. It's sort of and it's not off the edge, so to speak, right? So there's a value there. That's could dereference, find out what that value is, and do a binary search to figure out where that is in the sorted list that I just found, the sorted array. Again, everything's sort of reversed from right to left, but and I'm going to find not only that, but I'm going to find the first value, the pointer or the iterator that points to the first value that's strictly larger. So not greater than or equal to, but greater, strictly greater. And then I'm going to swap that value that's greater with the value that I found on the left side. Yeah, swap those two. And now everything is still sorted from right to left, but now that sequence, because if it's sorted sort of from left to right, would be in decreasing order. It's just slightly further along, right? Slightly larger, I think. Yes, is that right? Mm-hmm. I found the first value that's larger than the left side and swapped with the left side. So now this larger value is now further to the left. Yeah. So this permutation is now lexicographically greater. Lexicographically greater. This, I think, is what they want, lexicographically greater. Yes. It was lexicographically greater. And then also reverse left to right. Oh, interesting. So perform that swap, and then where the left side is pointing, the right of it really is where the base would be. So I think it's to the right. Go ahead and reverse all of those elements now. So they were sorted, performed a swap, reversed everything. So the reason why you reverse everything is that basically I found, because all those elements were sorted in from right to left in ascending order, I wanted to extract the element there that was just larger. So I'm going to take all those elements and sort them in the reverse order, but I'm going to take the first element that's just larger and swap it with the first element that's just outside of that set of sorted elements. It's pretty confusing, actually, to explain in English. It's like not that easy to explain, articulate. And what I'm going to do, I'm going to find that first element that's larger, or the first element that's larger in the set versus the first element that's not in the set. Swap those two. Now the elements in the set are actually a little bit smaller, of all things, but also now the element to the left of all that set is now a little bit larger, and the lexicographically smallest element of all of the possible, not element, but sequence, lexicographically small sequence of all the sequences that have that sort of new element in the front of that set of other elements would be the one for which those elements on the right side are all sorted in ascending order, left to right, rather than right to left. So just reverse them. Yeah, that's really confusing. That's like really hard to explain in English. It's like really complicated. It's not that crazy. It's just not that easy to explain and not that easy to kind of follow. That's what they're going for here. So that's why you reverse those things. Is because now it's that set is now as small as possible. Whereas you kind of jump ahead a little bit by swapping that element on the left side, and then bring it all back to that sort of the smallest element that has that sort of left element swapped. Yes, quite a thing. I think the next thing is, okay, fair enough. So that's how you could do all permutations. But what about K permutations? What about K combinations? Just regular combinations. And is there a way to do this that's less complicated than that? Like, is there a way that's totally different from this that'll work just fine? Are some of the questions to ask. So one idea is, I mean, they say these are all unique characters anyway. So that should make things a little bit easier in theory. I think. Sorted distinct lowercase English letters and a number as arguments. Sorted distinct lowercase English letters and a number combination length as arguments. Okay. Initializes the object with a string characters of sorted distinct lowercase English letters and a number combination length as arguments. a string characters of sorted distinct lowercase English letters and a number combination length as arguments. Sorry, my mind is wandering while I'm reading that. I watched a video about stockfish earlier, and I'm like, now my mind is like wandering. It's a chess game playing AI, and I was like, huh, is it that simple? Like, is there a way to make that better? I think there's probably a way to make it better than the way they're currently doing it. I think so. But I was like, is it really better though? Is it really? I don't know. Anyway. Initializes the object with a string, characters of sorted distinct lowercase English letters, and a number combination length as arguments. Okay. So yeah, another way to think about this is like you're gonna loop through. You're gonna take the combination length tells you the size of the subset, and then you're gonna loop through in sorted in lexicographical order all of the subsets of that size of these letters, and the letters are unique, so the subsets are a little bit simpler, I suppose. In fact, they're all distinct from each other. The subsets. I mean, they would be distinct anyway, but they're definitely distinct in the sense that none of them are going to share an element, right? Whereas if you had copies of lowercase English letter characters, then technically you could have some of these combinations. Even the element IDs would be unique, but the elements themselves, if they were shown as a character as a string, would be not unique, right? Like you have a sub 1 and a sub 2 kind of a thing going on, where a is a character, or q sub 1 or q sub 2, whatever you want to call it. Interesting. I think Excuse me. Object with a string characters of sorted distinct lowercase English letters. Yeah, I think the return values should be all sorted too. And I mean, my first thought is just for loops on top of for loops. Like you basically just have a excuse me, something like has a few ways you could do this. You just have something like a backtracking algorithm, and excuse me, I mean you can do that, and you basically you pretty much just save where you are in the backtracking algorithm each time, return another element each time. There aren't that many. I mean, fair enough. Combinations, there can be a lot of combinations, so something like this you really can't have that many characters, and 10 to the fourth call is not that many. So yeah, I mean you could just set up a backtracking solution where it just backtracks from one step to the next, and pretty much will return. Oh, it has next. Okay. Oh, that's interesting. Oh. Okay. Okay. Interesting. Excuse me. Yeah. when you're using Python, you could use you could use like a yield, like a generator, to do this for the backtracking, I think. But I don't know how you could do that exactly in C++. The exact same thing. I'm sure you could do something similar, but I have to think about it. It's like because you could just use the yield expression directly in Python. It's like very straightforward. But C++, it's a little more. I think you can still do the same thing. I think you have generators in C++, something like that in C++. You probably do. I think you do. I remember seeing something like that 11 years ago. Input iterators. Okay. Okay. Got it. So yeah. All right. Fair enough. It's just I don't need exactly that though. You know. I'm gonna try to do it this way. The problem. You know what I probably would want to do? And it's ironic because this literally is asking for an iterator. It's literally saying like, well, define an iterator that does this, which is kind of what that post was suggesting, that iterators are basically, input iterators can basically be considered input iterators could be considered generators, or could be considered to be related to generators. I think yeah, I would need to save some like internal state. Do I need to keep track of a stack maybe? All I need yeah, the thing that's awkward about this is like I don't necessarily want to keep track of this call stack. Like as part of the class, it's a little bit awkward. Yeah, because I want to use recursive backtracking. That's like the way to go. Recursion. It's the easiest way to go. But the problem with that is excuse me. The problem with that is saving the state of a recursive sequence in a class is like not the most obvious thing. I think you could just use the stack. I think that's the way to go. Sort of emulating the call stack, so to speak. How would this work? I mean, another way of doing this is for easy way of doing this, just generate all of the combinations immediately, and then all of the just do it in one shot, and then all the next iterators just gives me the next one. That's pretty funny. Excuse me. I don't know if that's good though. I think 15 factorial is pretty big as far as numbers go. And yeah, 15 choose like 10 or something is. I think the largest value is 15 choose 7 or 15 choose 8, which is probably a pretty big number, quite frankly. It's kind of like I don't know, if you divide it by 2 a bunch of times, it's like around 9 factorial, right? Because 15 divided by 2 is 7.5, which is around 8. So it's rounded up to 9. That would be 9 multiplied a few times, 9 times 8 times 7, etc. Roughly. And so that would be kind of like 9 factorial times 2 to the 8th. Something like that, around there. Not exactly, but it's approaching that. give or take a few give or take a few numbers, which to the 8th I think is 256, and 9 factorial. I don't remember that offhand. That's a big number though. 5 factorial is like 4 factorial. I think is 24. 5 factorial is like 120, right? Yeah. 6 factorial is like 720. 7 factorial is like 50,000 or something. 8 factorial is like 400,000. 9 factorial is like 4 million. So I've got like 100 million. That would be, that would be like 100 million things. So that's probably not reasonable. Oh no, I can't store that. I can't just calculate the whole thing directly. That'll take too much. Excuse me, that'll take too much computation. Okay, how about the next thing? State by state, I could save just where I am. Well, no. If I'm only going to 10,000 calls, I only need to go up to 10,000. So actually, I actually can do this. Yeah, it's fine. Yeah, I mean, whatever. This is like I don't want to go through so much effort. I don't want to make this so complicated. I probably could technically do some like fancy call stack, emulate the call stack stuff, but I think that's way more effort than I need to do here. It's like it's too much time, and I'm sure it's not that hard to do. It's just, well, it probably is pretty messy anyway. Like no matter what I do, it's probably pretty messy. So we'll try to do it the following way. We'll do a vector of strings, and this is going to be combinations, and I'm going to say comms.reserve, and there's like a special constant here, static int const int bound, which is 10 to the 4th, and I'm going to reserve 10 to the 4th entries into my vector of combinations. I'm also going to have int I is 0 index, and we're going to go ahead and say basically if I is less than bound, yes, 10 to the 4th, yes, that's fine. Always return empty string. So I plus 1 is less than bound. Increment I. Actually, no, it should return I and then increment I. This is a little bit awkward. Do it this way. Actually, I could do it this way. That's maybe easier than copying the whole string in that way. As next is just return I is less than bound. There's actually yeah, that's actually what I want. That's more so what I want. Okay, and then I'm just gonna generate all of these directly. Just keep it simple, and I can use a private best for that. Yeah. How does this work? It's gonna be if constant index, not index, but just position. call this combination length. Yeah. The position is greater than or equal to the length. Then return. Stop there. Actually, it should be comms pushback. Call it S. Yeah. And what I'm going to do is S plus equals and S dot pop back. And it's going to be position plus 1. So I think I'm confusing myself a little bit here. There's a particular index. Oh, yeah. So there's a for loop, right? And there's another index. This should be index, not I. So constant I. I don't know if that's good, these different indices. Let's do, yeah, I don't know, current might be better. I don't know. I like to use these variables, so it's just do current. So what it is I is current plus 1, I is less than characters. This is confusing. Oh boy. Let's do, it's not position, it's just remaining is more like what I want, remaining. Right, let's do remaining, that's better. Okay. Remaining is less than or equal to 0, pushback S, return S plus equals. So we're gonna S plus equals chars of current, and then I'm gonna say pop back that character. If I is gonna be current plus 1, I is less than characters dot size increment I, and DFS on I, and remaining minus 1. Okay. A little bit confusing exactly what's going on here, but I think that works. And yeah, this is just gonna if comms.size is greater than or equal to bound, also return. So we stop once I get all of my combinations in there, then I stop too. Stop adding more. Yeah. Something along these lines. Let's see if this compiles. I think it's a little bit jumbled, my thoughts on that. How to do this a little bit much. Oh, okay. So I didn't get these. This, false, false, false. Okay. All right. Interesting. So what's the bound? bound is 10,000. If not has next, if has next, then we return, yeah, and then has next is index is less than bound, and index is less than, yeah, combination size, yes. Wait, what? What is going on? Did this not work correctly? I just got AB and that was the end of it. What? Remaining should be 2. Start off at 0. Current remaining. Zero to. What is going on? The 0 to add the first character, which is A, right? Should be ABC. So add A. Then start with B with one less character being 1. It's going to go through 1 and 2. Character size is 3, so we go to 1 and 2. So this starts off with this goes through a 1, and this is not true, so we skip that. We get down to, I think it's going to be less than 0, not less than or equal to 0. No. I mean, call it with 2, then we call it with 1. And when I call it with 1, with A, this then adds the value B. I then becomes 0, 1, 2. And this is 0, and this gets called. What is the issue? I think this might be the problem. I think this could be called here too. Oh, I see. Okay. Maybe that's what it is. It's a little bit confusing, but there's some logic involved there. It's a little bit complicated. Wrong answer. Okay, better, but not right. Okay. I got A, B, A, B, A, C, which it should be A, B, A, C, B, C. Better, but not correct. Not correct. I don't know what's going on exactly. I don't know what this is. It could be something like the following. Maybe what I need, actually. I don't realize it. Maybe this. Okay. No. No, not like that. didn't think so. I was like, I'm pretty sure that's not right either. Pretty sure this is the right idea. It's just something's not quite totally correct. What am I missing? I'm missing something important. I'm missing something important. Why does this matter so much? Shouldn't this not matter? What happens exactly? Feels like this should be a lot easier. I don't know why I'm struggling so much. Oh, does it not? Hmm. I don't know. Wait, what? Oh, yeah, this part. That's wrong. What is happening? Why? Doing something kind of foolish here, I'm sure. I think part of the problem is yes. Okay. So part of the issue is I think it's supposed to be like this. This is confusing. Yeah, I have to really think about this. Something weird going on here. Yeah. This is not quite right. Okay. Let's think about this. Part of the problem is that I could add this character and then I don't call this DFS, so I don't get to here. Yeah. Huh. I think this is supposed to go up here. And maybe this always pops off. We could try that. It's confusing. Yeah, there's some kind of technical details there. Like, not technical details, but just some issues here. There's some issues here with this. Okay. I don't know. G. That's confusing. Not obvious at all what's wrong. Okay. So, well, gee. It doesn't handle the last character correctly. That's the problem, right? It's actually kind of easy to see if you just think of it this way. It won't handle the last character correctly because if the last character is on current, and that's characters.size -1, then adding 1 to I, this will be false. It'll never enter here, and it'll just get popped right off. Which means that anything ending with the last character is not going to end up getting pushed back. That's basically it. So then I could say, well, okay, we'll make sure we do check that one. But then the problem is the value for I. This could be at the end, and then we have an issue because we would say if current is greater than or equal to chars.size, then we would not want to process that, right? Excuse me. But another issue is that I get the first thing duplicated for some reason now, which is not obvious at all. I get A, B, A, C, but I don't get B, C, and I have 2 ABs, which is weird. I don't know why I get 2 of those. So why would I be getting 2 ABs now? That's weird. I don't know why. Why would I get 2 ABs? Excuse me. I just get AB, AB, AC. What is going on? Why don't I get BC? Where's BC? Huh. Oh, I think I know what the problem is. Oh, I see. Okay. I think I had to call for each DFS. I mean, do I do -1? Maybe that's what I want to do. Yeah, it would be -1. That's what I want. And then I would do more like this. Right. Current +1 less than equal to less than characters dot size. Remaining, maybe something more along these lines. I don't know. Okay, now it's just all empty. Just doesn't do anything now. Okay. Why? The reason why I'm missing so much with that is what I had before is that I wasn't doing a for loop for the first character, looping over all of the initial starting points like I was just doing just the first initial character. So now we have a -1. Add 1 to current. But now it doesn't do anything. Remaining is 2. Add a character. Okay. And then add the next character. Should be B. Should be down to 0. And then, oh man, oh, not obvious at all. Why? What? Runtime error now. Oh, say it ain't so. Why is that happening? Wait a minute, didn't I just try this? Oh. I didn't submit it, right? I just used the test case. Oh, this is taking a long time. This is taking me a lot longer than I thought it would. Yeah, it's not obvious. I don't know. I don't know what to say. I'm surprised. This is giving me such a challenge. It's supposed to be pretty simple, actually. It's supposed to be pretty simple. How? Oh, that's why. Duh. I didn't realize. Yeah, okay, that's my mistake. That was my mistake. There we go. Oh my goodness. Of course. This is like Alright, let's try some of these. G. Invalid test case. Oh, okay. 1, 2, 3. Oh, I don't know how many there is. It's too many, is not enough. I don't know. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 1, 2, whoa. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we got to go to 26. 21, 22, 23, 24, 25, 26. Not a valid call to next. What? What does that mean? I don't understand. Is that maybe what? 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 Same. What is happening? It's not a. What do you mean it's not a valid call to next? What do you mean? What? What does that mean? Arguments are invalid? Huh? Are there not that many that have it? That might be it. I don't think this is okay. Oh, actually, that does make sense. Yeah, I didn't realize that. I see the problem. It just dawned on me there aren't that many ways to do. It's only 1, 2, 3, 4, 7. Choose 5. There aren't that many values. 7, choose 5. You could go to like A, B, C, D, F, G, H, I, J, K, L, M, N, O. That would be fine. And let me get rid of the printing. So I don't know what to say here other than I think I made a mistake of some kind. Okay, this looks pretty good. This looks reasonable. I'm gonna go for it. Could be wrong somewhere, some off by one error. Oh, it looks like I got it. Okay. Pretty good. All right, reasonable. Yeah, I mean, I don't know. I think I need a break after that. I was like, so many things involved with that. My goodness. What's Chad doing? Okay, Chad is silent. Chad has no opinion. All right, so we'll do 4 more, submit it 4 more times and then take a break. I don't know if we'll come back. I mean, I'll probably come back for more, but more work, more problems. Definitely. Oh, there we go. Hey, pretty good. 100%. Not bad. Not too bad. Yeah, okay, it's reasonable. I was expecting this not to be that good, that quick, but yeah, it's okay. This works. That's 1, 2, 3. Let's do a couple more submissions. So thank you for watching. If you liked the video, give it a like and subscribe for more. I'm going to go ahead and take a break here because, I don't know, that took a lot longer than it should have. That was like annoying. It just took longer than it should have, and I'm annoyed. It took longer than it should have, and I'm annoyed. These things are all reasonable. I think the first thing to consider. Submit it one more time. Okay. Oh, that also beats 100%. Oh, that's pretty cool. That's cool. I got a 0 millisecond too, which was super fast. What's annoying about this is it's super simple, and it should have been super simple. It should have been like extremely simple. I just didn't think it all the way through some parts. You know what I didn't think through? This DFS. The fact that I need a for loop for the starting point, and so I need to actually put these inside the for loop and use a -1 here and increment here. Like where I put my incrementing values was kind of the issue. That was sort of the problem, I think. Yeah. And yeah, this was a good idea too, to bound how far I go, depending on how many calls. Because I know there's only going to be 10,000 calls, so I could just reserve the memory, and also make sure I don't go past that, and sort of stop early. And then also I can do the yeah, these are pretty easy. Once I basically just generate all the possible combinations I might want, In a lot of cases, there aren't that many, but it's also bounded anyway, so it all kind of works out. And then on my next calls, this is very straightforward. Just note, basically amortized constant. It's pretty much amortized constant. All the calls, as well as the actual like first population. Sort of what I went for, which I think is okay. You know, that's like, it's reasonable. It's definitely awkward to try to like pick up where these, not search state, but like where, like if I wanted to write code that like, you know, performs this depth first search in like either pieces or one at a time, you can do it that way, but I think it's really awkward, as I mentioned. Like, it's pretty weird to do that. And it's definitely like you have to kind of emulate your call stack on some level, which I think is not really the best. Yeah. So interesting. Pretty good. Pretty good. I like this. I think this is good. I think it's good. I wish I was able to do this a lot faster. I wish I had done this in like a few minutes rather than like an hour. That definitely would have been preferable. I don't know, like this is what I was thinking, but somehow it's not what came out. This is pretty simple, pretty easy, quite frankly, to do it this way. Just trying to think of like what could I do differently in the future. Yes, so this index does have to be less than the bound, because the bound is a bound on the size, right? Which means less than bound, yes. And then also this other one too, because sometimes the size is smaller than the bound, and then you also want to have this check too. As long as you're less than both, and then you have something. And it's also, this is also a nice easy way, because when you return, you can't run any more commands, so you've got to increment the index first, and then you just decrement when you return the combination value. Is a little bit better than like copying the string and then incrementing and then returning the copy. Something like that, which is an alternative way of doing this. This is like, yeah, you want to bound terminate early, because you don't want a list of combinations that's greater than or equal to the size of the bound to that size. So terminate early there, and then each of the combinations that are going to be entered are going to have the remaining characters less than or equal to 0. So I want to have enough characters accounted for. And the reason you would do it inside the for loop, update the s value, and then pop it after calling the recursive function is because, and also start with an index of -1, because I want to start my recursion at every index of the set of elements from left to right. But I also want the next character to be not the same as the previous character. So I want to add 1 here, and I also want to have this loop, but I also don't want to have the loop inside here too, because I could have had the loop over here, which was kind of the problem I was running into, is that I wasn't getting all of those initial starting points in my solution because I didn't have this for loop for the first character. So modifying this slightly, I'm able to achieve that, which is not the most obvious thing. Not the most obvious thing. But there it is. Yeah, that works. I mean, that's pretty reasonable. That's fine. Also need to worry about having this being equals or not too, which was something that was confusing before. I was kind of getting really very confused about that. Don't have to worry about all that anymore, because I add the character and then do the check, right? Add the character and decrement the remaining and do the check all at once. And then pop off the character for the next one. So yeah, this is very clean, very simple, pretty good. Kind of fawning over my own solution at this point. But hey, I don't know, I got 100%, it's faster than everybody else, you know, gotta take a moment, take some pride. And yeah, I don't know, that took a really long time. That didn't need to be that hard. I don't know what to say about that other than I guess you just need to practice more. Just more practice is all, I guess, or something like that. I did spend quite a bit of time trying to think of a solution that doesn't use the depth first search in that way. So that's also big. That was the time sink, because I didn't realize like, oh, this could be done pretty quickly pretty easily with a simple approach. It just didn't occur to me. I was kind of trying to be a little more clever, which is not necessary for this question, given the constraints, the requirements. So yeah. Thank you for watching. Again, like the video and subscribe for more if you like the video. And I will see you later. I'm gonna take a break. I don't know what exactly I'm gonna do, but I'll just, I don't know, hang around for a while. Just stare at the ceiling and think for some time, which is what I like to do typically. Plot out my next moves here. All right, take care.